Welcome to the latest in Mongabay's webinar series for journalists broadcast to you live. If you're tuning in on YouTube, you can also view this on our LinkedIn channel and interact with us there. That said, I do recommend that you subscribe to our YouTube channel so that you can be notified when this webinar is edited after today. So today we're focusing on how to cover coastal climate solutions. And as with many topics that we cover here on these webinars, we're seeking your pitches on them. So if you have a story idea that you'd like to pitch to us on coastal climate solutions, please go to mongabay.org, click on the opportunities page, scroll down the page, and then click on coastal climate solutions. We appreciate all the pitches that you send to us, but we also encourage you to pitch your story idea to other outlets, if not to us. And don't forget to sign up for our occasional email newsletter, which you can also find there on the opportunities page, which shares new paid reporting opportunities and job openings here at Mongabay. And like always, we're going to go through a slate of 10 questions today with our panel. And at the conclusion of the hour-long session, we'll be opening up the floor to your questions. So if you got any thoughts or comments or questions in the meantime, just go ahead and drop them in the chat on the platform that you're tuning in on today, and then we'll do our best to address them at the top of the hour. I'd like to go ahead and introduce our fantastic panel, starting with Erica Gies. Erica is an award-winning independent journalist who writes about water, climate change, plants, and critters for Scientific American, the New York Times, Nature, Mongabay, The Atlantic, The Guardian, National Geographic, The Washington Post, and others. She is a National Geographic explorer and the author of Water Always Wins, Thriving in an Age of Drought and Deluge. Erica, it's a pleasure to have you here. Thank you so much for joining.
Thank you for having me, Mike. I'm really happy to be here.
And also joining us today is Dr. Richard Lilley. Dr. Lilley is a co-founder and the chief development officer at Project Seagrass. He has spent the last decade developing and implementing seagrass research, conservation, and restoration programs in collaboration with coastal communities. Project Seagrass works internationally to develop tools to improve seagrass ecosystems, monitoring, and management. And he has worked on seagrass research projects in the Caribbean, the Indo-Pacific, North Atlantic, and Mediterranean bioregions, with a personal focus on the sustainable supply chain management of small-scale capture fisheries. RJ, thank you so much for joining us today.
Pleasure. Thank you so much for having me. Those instructions are always a bit of a mouthful, so well done.
And also joining us today is Dr. Nicholas Murray. He is a senior lecturer in global ecology and conservation at James Cook University in Australia. He has published extensive scientific literature on ecosystem dynamics, Earth observation, global change, coastal ecology, and conservation science. His work has been recognized with awards including the Eureka Prize as part of a global conservation team, the IUCN Commission on Ecosystem Management, and the Australian Academy of Science Aspire Prize for Innovation. Nick also leads the International Global Intertidal Change Project using Earth observation archives to comprehensively monitor change across the world's coastal ecosystems. Nick, thank you so much for joining us this morning out there in Australia.
G'day, Mike. Thanks for having me along.
And of course, I'm your host and moderator, Mike DiGirolamo, the Audience Engagement Associate here at Mongabay. So to recap, if you're just tuning in right now, we're going to be giving each panelist an opportunity to address a slate of about 10 questions. And then about an hour from now, we'll be holding a 15-minute audience Q&A for your questions. And again, if you have a comment or a question in the meantime that you just want to let us know about, drop it in the chat on the platform that you're tuning in from, and we're going to do our best to answer it at the top of the hour. And just as a reminder, this webinar is going to be on demand on our YouTube channel immediately following this broadcast, but it's going to be lightly edited in about a day or two to include timestamps and resources that are shared during this broadcast. If you registered for this webinar via the Google form, you'll be receiving a link to this published webinar and also a brief survey, which we would very much like for you to fill out. And then this webinar will also be accessible on our blog at the original registration page, as well as the event on LinkedIn. So with that said, let's go ahead and get started. So first question, what exactly are blue carbon ecosystems and why are they so important for coastal restoration and combating climate change? And anyone can chime in.
Who wants to go first? I guess, I mean, blue carbon broadly, I think refers to, we use it to refer to anything in the marine space, as opposed to, I guess, green carbon, which I think is generally the term, at least we use up here for anything which is in the terrestrial space. Blue carbon can incorporate anything from a whale swimming out into the middle of the sea and dying and descending to the ocean depths, right through to carbon which is stored in coastal ecosystems. And I think the real focus on coastal ecosystems tends to be driven by seagrass meadows, mangrove, salt marshes, and the interest there is often in the carbon that's actually buried in the sediments beneath these habitats rather than the above ground biomass themselves. I think that would probably be a fair summary if anyone else wants to chime in.
Yeah, I'll just add that these kinds of ecosystems can store 3 to 5 times more carbon dioxide than a lot of forests. So, when people think about the idea of storing carbon dioxide in ecosystems, trees get a lot of attention. But in fact, wetlands of various kinds are super stores of carbon.
And then I can also jump in there, Mike. One other thing that's really important about blue carbon ecosystems is not only their carbon sequestration service, it's also their incredibly important role they play in buffering human populations from storms and sea level rise, and a range of other ecosystem services for coastal communities worldwide. And with about 10% of the global population living in these low elevation coastal zones, the more we can maintain blue carbon ecosystems and vegetated coastal ecosystems like salt marshes, mangroves, seagrass meadows, the more they can continue to provide their important services to those communities.
Yeah, absolutely. I mean, just to build on that, I think that's a really critical part of the sort of management of blue carbon ecosystems, and why they're important is because they do so much more than just carbon. I often think really of carbon as a co-benefit to a number of these other ecosystem services that these habitats provide. So to take seagrass meadows, they're really important for fisheries, so really important for food security. Seagrass meadows are often a nursery habitat, so a habitat where baby or juvenile fish and crustaceans may spend the early years. Really important for sediment stabilization in that coastal space. We know that they help to cycle nutrients as well. They're havens for biodiversity. So these coastal habitats really do offer a whole myriad of services beyond just that capacity to store and sequester carbon.
Yeah, I completely agree. And that has been the primary focus of my reporting, is how these intact ecosystems or restored ecosystems can help to protect the human communities behind them just by their natural buffering capabilities. And in fact, tidal marshes, for example, can actually keep up with sea level rise if they have enough time, space, and sediment. And sediment scarcity is a significant problem due to dams and dredging for ships and whatnot. And I think there's a question where I may talk about this in more detail later. But I'll just add that there was a study that came out a couple of years ago that showed that tidal marshes not only can keep up with sea level rise, but can store 2 to 9 times more carbon dioxide if they don't drown too quickly.
Great, thank you all. I'm gonna go ahead and just go, for the sake of time, move on to our next question here. So, what kind of changes to coastal environments are we seeing, and what are some of the most interesting and successful or promising solutions to them?
I'm happy to start with this one. Well, I mean, I work on developing a global understanding of change of coastal ecosystems. I use millions and millions of satellite images to analyze those changes. And one of the major changes we've seen for blue carbon ecosystems and other coastal ecosystems as well in recent times is just enormous losses, which are caused by the transformation of the world's coastlines to these sort of human-centric environments. In the last 20 years, for instance, we've seen about 4,000 square kilometres of mangrove, salt marshes and tidal flats be lost, primarily due to extensive coastal developments. In some parts of the world, such as Asia, in fact, we can see that more than half of some countries' coastlines are anthropogenic coastlines now. They're seawalls rather than blue carbon ecosystems. So habitat loss is sort of the most obvious one, I think. But this is not a simple dynamic that we see in coastal ecosystems, because coastal ecosystems are really dynamic. They're able to respond to drivers of change, such as sea level rise and those disturbances as well caused by human developments. And so they're able to move. And so sometimes we're able to also detect new coastal ecosystems in places where they didn't occur in the past. And that's a really interesting dynamic that coastal ecosystems are able to sort of buffer to some extent some of the impacts that occur to them due to coastal developments. Just a couple of other ones would be subsidence. They're sinking all around the world, particularly in places where coastal sediments have been built on, and sea level rise itself can have an enormous impact on the ability of these coastal ecosystems to sort of maintain their extent over time.
Yeah, I'd like to add that it's important to look upstream as well. Water Always Wins, my book, is largely about freshwater and partly about coastal issues. But, rivers are really critical portals to deliver sediment to coasts. And so in many places around the world, rivers have been dammed, and the dams block that sediment from reaching the coast. And so a lot of coastal land loss that happens, and loss to those coastal ecosystems for this very critical building material are due to these kinds of upstream impacts. And then in other places around the world where there are fewer dams, but a lot of land development, there's a lot of sediment erosion into rivers that ends up then depositing too much sediment into coastal and marine ecosystems. And so in some places, this can, cause a lot of ill health to corals, for example, because, it smothers them, and the algae grows over, excessively, et cetera. So just a thought about, thinking about that land to coastal marine delivery as well.
Yeah, I think to build on, or to give an example from Scotland, so I'm calling from Edinburgh today, and listening to those sort of macro processes, the big processes around the world in terms of things like sea level rise, and how that's having, well, sea level rise is uneven to start with, but how that's impacting different areas in different ways, but also how the change of the coastal, just the change of the coastal zone, has been massive. And if I think back probably actually before satellite technology, the Firth of Forth here, the estuary just outside Edinburgh, I think historically it's estimated we've lost about 50% of the intertidal. There's a lot of hard infrastructure that's now gone in. The upper reaches of the Firth of Forth have been straightened. There's been lots of drainage and additional sediment into the estuary now. And then, so there's all that sort of different hydrodynamics now at play, which have completely changed the face of the estuary and the way that it works. But there's also been that loss of coastal ecosystems. So there's been the loss of the salt marshes. There's been a loss of the seagrass meadows. And actually, there's been loss of other key habitats as well, things like oyster reefs that used to exist from pretty much where the bridges are today out to Gosford Bay in East Lothian, one of the biggest oyster reefs in Europe, and mussel beds. There's a town called Musselburgh, which is named after these big mussel beds that occurred on the just off the coast there. And all of those organisms would have helped bind the sediment and help keep it in place. And so, when we look at our coastal zone, we're actually looking at a very radically altered sort of seascape now today, and that in itself has a big it just has a really large impact on how that coastal landscape seascape interface works, and how the coastal zone is really operates, I guess.
Great, thank you very much. So I want to go ahead and talk a little bit about seagrass meadows then. This question is actually a little bit directed at you here, Richard. Are there any places in particular in which seagrass meadows have really shined in helping to improve water quality and increase biodiversity that you want to talk about? And by the same token, is there potential there for it to help reduce coastal erosion as well?
Yes and yes. So I think the water quality issue with seagrass meadows is pretty critical. Certainly one of the biggest challenges I think we face in the UK around the management and conservation and restoration actually of seagrass meadows is water quality. And I think really recovery of seagrass ecosystems almost goes hand in hand with that pressure removal. So restoring a seagrass ecosystem isn't just about planting seagrass. There's no point in planting seagrass if the pressure's still there. And so I think one of the most successful seagrass restoration projects that I know of is actually in the Chesapeake Bay in the States. Within that Chesapeake Basin, I think they've restored something in the region of 3,600 hectares over the last 20 years. But that hasn't been through planting alone. That's also been through pressure removal. And then the seagrass has got to a stage where it's self-facilitating. And so there was a paper released, I think it was in 2020, by Bob Orth's lab and that wider team, where they've seen not only the ecosystem, like the seagrass spread and recover, but linked to that, they've seen biodiversity increase. They've seen things like the biomass of fish increase, the biomass of invertebrates increase. And they've also seen increased amounts of carbon and nitrogen cycling, so like carbon sequestration. So the ecosystem services have returned with the return of the seagrass meadow. That's probably one of the most famous examples of like seagrass recovery that I know of. Another really good example actually is at the moment, there's some amazing work being done in the Netherlands. There's a Laura Chovers at the University of Groningen in the Netherlands. They started restoring a Zoster mariner meadow in the Wadden Sea 5 years ago. And they're now at 650 hectares of seagrass coverage, which is a very rapid return of the meadow. But again, it's that self-facilitation. The pressure's obviously been removed, and it's allowing that seagrass to recover naturally. So I know they do have biodiversity data coming from that work, but I don't think it's been published yet. So, but keep an eye out for Laura Chovers' work there. And then from a sediment stabilization perspective, actually, I've got an example here from the Firth of Forth. So there's an old castle, essentially, which is perched right on the edge of the estuary, and the landowners are obviously concerned about sea level rise and coastal erosion. That particular stretch of the estuary, there's more erosion than sediment deposition, and so they've actually put in some hard infrastructure to protect the old building. But we've been speaking with them about the possible climate solution with regards to protecting that asset via nature-based solutions. So whether salt marsh, seagrass meadows, and actually thinking more about green infrastructure rather than grey infrastructure or solid infrastructure could be a route forward there. Because I think, as Erica spoke to earlier, these ecosystems can help trap sediment, and so they can actually help build up and keep pace with sea level rise as it occurs.
Great, thank you very much, RJ. Is anyone else here have anything to add to that, or anything else to say about seagrass meadows? No? Okay, no worries. We're going to move on to our next question, and this one is about mangrove restoration. So mangrove restoration projects are pretty high profile. They get a lot of attention in the news. And I'm curious to hear from you all, or anyone really, what can journalists learn from past mangrove restoration efforts that will help them critically examine them in the future? And why does it seem that they often fail? And additionally, what aspects of mangrove restoration do you feel need more media attention?
I'm happy to go first on this one. Well, one of the things we see with remote sensing are some really large changes to mangrove extent. So we see growth in mangrove extent at quite a large scale in some parts of the world, including mainly in Asia. And often when you drill down into why we're being able to detect these new mangroves on Earth so quickly, they're often a really massive monospecific planting of a single mangrove species. So just lots and lots of individual mangroves just planted, frequently on an ecosystem that might not actually be mangroves. So we work on tidal flats here a lot in my lab, and these are unvegetated, but the places where mangroves are being restored are sometimes on an ecosystem that in its own right is not mangrove. So it's sort of planting the wrong species or a single species to represent a complex ecosystem, which often has many more than one species in it, in the wrong place. So planting in places that are either not mangrove in the first place or unlikely to be mangroves. these sorts of things can contribute to that high failure rate, just planting mangroves right in the wrong place and not really accounting for the complex dynamics that these ecosystems need to be able to persist.
Yeah, I would add that part of the reason that mangroves are cut is because local people, want to produce carbon for sale, or they want to build fish farms. And so, they have economic motivations, and some of the more successful projects have collaborated with local people to involve them in the restoration in some way, whether that is, growing shrimp within the mangrove roots in a more natural way for, an increased price in the marketplace because the shrimp are protected more sustainably. And then just to add on to what Nick was saying about single species or like monoculture plantation type planting, this applies actually to tree planting around the world, where people kind of have like a single goal without thinking about the complex system that is appropriate for that area. And if you have a single species plantation, it can be vulnerable to all kinds of things, whether it's fire if it's inland, or bug attacks, or storms. They're just weaker because they don't have those complex things. And also, there's an increasing body of science showing that tree planting generally is not very successful. What tends to work better is if you stop the human thing that is causing the damage, whether that's overgrazing or cutting the forest or whatever, and then protecting the area, instead of using that money for tree planting, using it to protect the area, and then allowing the area to kind of reseed naturally. And when that happens, there tends to be a much higher longevity rate.
I think that the same could be true for saying like seagrass is the wrong seagrass in the wrong place. I think there's one of the challenges I think we're faced with is the metricizing of, like, how many trees can we plant, or how many seagrass hectares can we plant, or whatever it may be, without actually taking into account that these are natural systems and they naturally fluctuate, and we really should be thinking about the seascape and the connectivity and those natural systems. I don't work with mangroves, but I was at the UN Ocean Conference last year, and there was an example there of, I think a road had been built which was cutting through a mangrove forest, but the road was actually preventing the flow of the incursion of saltwater, basically behind the road and into the mangrove system. And so on the back side of the road, so not the seaward side, the landward side, all the mangroves died there. And so there was I can't remember if it was a corporate, or if there was a big movement towards, we need to go and plant some more mangrove trees. And again, that's not helping, because the reason the mangroves aren't living is because they haven't got the salt water. So what they naturally needed to do was just put, I don't know, it was essentially tubes underneath the road to allow the water in and out again, to allow the system to recover naturally. What they didn't need is lots of people actively going and planting mangroves in a place where the habitat was no longer suitable for mangroves. I don't know if you know that example, but it's that kind of issue where we're trying to actively do stuff when actually it's about the system and how the system interacts.
Yeah, I mean, I totally agree with that. Coastal ecosystems are so dynamic. They're just so built on a whole bunch of feedback mechanisms among different ecosystem types. Something that happens in mangroves can influence the seagrasses, the coral reefs, or the salt marshes right next to them. And so if I had to give some advice to journalists working on just critically appraising a coastal restoration project, it would be to really open the conversation about how complex the system is, and does this project actually address those complexities? Does it improve connectivity among adjacent ecosystems? Does it account for the super important process of regular tidal inundation in any coastal ecosystem? Like Richard just said, no tidal inundation generally means no coastal ecosystem. So all of those sorts of physical and biophysical feedback mechanisms in the coastal zone matter. And a totally functioning coastal ecosystem is dynamic. It's not just a single tree that's there and stays there. It can move around, and it should be dynamic and should be able to handle minor changes in sea levels, storm impacts, those sorts of processes. And the way it can do that is by being allowed to be dynamic, so a coastal restoration project with a view for a functioning ecosystem that can move and migrate and adapt is really important in my view.
One of the researchers that I interviewed for a story I did on tidal marsh restoration in San Francisco Bay called that dynamic stability, which I love because, it sounds like an oxymoron, but in fact, if you think about it more deeply, it means exactly what Nick was just explaining.
Yeah, I think we also need to embrace complexity. I think, I don't know whether this is a trait that's been brought in from sort of terrestrial, like ring fencing land and saying, right, we're going to plant some trees in this space. But, when we work with seagrass restoration in the UK, and if we're restoring seagrass over 2 hectares, we don't want that to be a monospecific seagrass meadow forever. We want that to, turn into a natural seascape and to have bivalves enter, and for it to become a seascape rather than just that seagrass meadow in isolation. And so, when you start thinking about metricizing things like carbon storage in the meadow, that might go down if other habitats incur on it, but that's what we want to happen because that's what a productive natural ecosystem looks like. So, there's that challenge, I think, with humans. We're wanting to metricize and quantify and put money on values on all of these habitats, but actually we need to be thinking much more nuanced and just accepting it's a complex system.
I'll just add hashtag not all humans. So I write about this a lot in my book, and I think it's actually a part of like Euro-American colonial settler mindset to have that really single focus problem solving when it comes to anything. And it's because, we put ourselves first and we're the most important, we're separate from nature, we're better than nature. And therefore, we really have that, we have too much carbon in the atmosphere. Like, let's plant a bunch of trees to suck up the carbon, or let's, put it underground. If we need water, let's build a dam and bring it from somewhere else. If we're worried about flooding, let's build a wall. And, again and again and again, we see that we are causing the rampant destruction of all of these natural ecosystems that provide so many services to us that we do not count at all in our economic system. They're not valued, which is why they're destroyed. And when we're coming up with a cost benefit analysis for one of these single focus solutions, we don't count that degradation against it. But when I say not all humans, of course, there are many people around the world who don't put humans at the top and in fact understand that humans are part of these complex systems. And they have an ethos of caretaking. With rights to these resources comes responsibility for caretaking and ensuring that they continue to be productive. So I think that mentality is really, unfortunately, deeply, deeply ingrained in the dominant culture. And but there are many examples of many peoples around the world who do have a different perspective and a different philosophy that leads to a much more resilient environment around us.
These are all really helpful points, and thank you so much for putting those in. I want to, in that same vein of nuance, I want to shift the topic now to sea level rise. As some of you actually mentioned earlier, it obviously doesn't impact all places equally, and it'll happen in some places faster than others. But that said, some countries have more resources to deal with it than other countries. So the question is, what questions should journalists be asking to address these inequities?
That's a really tough question. I mean, I think we're starting to see some answers in terms of, what happened at the last COP in terms of actual funding for support of lower income countries. But I think there's also something that one of the sources in my book called hydrocolonialism, and that is more with respect to freshwater systems, like the tendency of the World Bank and the IMF to extend loans to countries, but only if they're going to build a giant dam, even though we've already seen all the destruction that giant dams bring. But in many cases, that is replacing or displacing a more sustainable approach that people in that area have used. And, there's long been a discounting of traditional ecological knowledge and people's close knowledge of the land and what works in their area. And so I think that's part of it as well. It's a little bit adjacent to your question rather than a direct answer, but I think, keeping in mind that local solutions may be the best solution for that local area, I think is really important.
Yeah, I agree. I think the solutions will really be sort of unique to place, won't they? I mean, even within, it's not from a global perspective, even within the UK, we know that there's different regions of the UK which are going to be more affected by sea level rise. So, for example, in the southeast of England, we've got a lot more low-lying land, and we're already seeing the sort of start of saltwater incursion, and so there is the need to have a very frank conversation about how do we adapt to that, and what does that look like, and is that the case of arable farm being lost? Is that actually the case that there are certain towns and villages which will can they be saved, or should we just let nature take its course there? So there's, whereas in, let's say, up in some areas of Scotland where you've got a much steeper drop into the sea, the sea level rise won't perhaps have such a big impact because there aren't those coastal communities in the same way, and there isn't that population density. So yeah, it's going to be uneven. I think there's going to have to be place-based solutions to those impacts.
Yeah, I wrote about a place in Southeast England that is doing managed retreat, Selsey, and the area actually has a long history of being incredibly dynamic. There were times when it was more connected to the sea, times within human history, and there's been some really fascinating archaeology there and mapping of the fluctuating coastline over time. But in recent centuries, there had been farming there, and kind of marginal farming, not great land. And so they negotiated with some of those farmers to sell their land and return the water to tidal marsh. And, in so doing, that land, it is absorbing some of the energy and some of the water. So it is actually protecting nearby areas more. So, it can be hard to have those discussions to leave a community. One farmer I interviewed, his family had been farming that land for 400 years, which, in North America, that's kind of hard to imagine. But, he was for it. He sees what's coming, and he was happy to be a part of the solution. And, in this case, he was compensated. Whether governments have enough money to compensate everybody who's going to have to leave is a question. But in fact, the Union of Concerned Scientists did a report a year or two ago looking at, how much money would it take in the United States, for example, to buy people out of lands that were going to flood in the relatively near future. And, it was like $1 trillion, which sounds like a lot. But then when you think of the money that was suddenly generated in the United States for COVID relief, it's definitely possible if people decide that they have the will to do that. Obviously, not all countries have those kinds of resources, but retreat and returning space to water is definitely going to be required and is already being required.
On that note, since Erica, you've already started to breach upon some of these adaptations to sea level rise, I was going to ask you all what cities or communities or countries are adapting to sea level rise particularly well, if at all, and what locations should journalists be keeping an eye on as that process unfolds?
Well, I can talk about the San Francisco Bay Area, which I reported on in Nature in 2017, and it's also in my book, which came out last year, so updated information. And San Francisco, like many places along the coast, had filled in or built on about 90% of its historical marshes. So much had been lost. And starting about 30 years ago, people all around the Bay, that's 9 counties and I think 101 different city governments, had started to restore some of the marshes. And the idea at that time was like for recreation and also habitat restoration for endangered animals. Actually, like in the 1960s, there started an environmental movement called Save the Bay. And that was a reaction to this really extreme filling in of the Bay and an Army Corps of Engineers proposal that would have filled, more than 2/3 of what was left. And at that point, people said, no, this has to stop. And so it's been this process over decades. And then about 10 plus years ago, people who are working on it, and this is governments, scientists, and that's also like a really kind of forward-looking model of collaboration among many different entities. They decided like we have to prepare for sea level rise. We have to return as much of the marsh as possible, as soon as possible, to protect against sea level rise. And so with the initial restorations, I think they had restored like 24% of the Bay, and their target is to get to 40 or 50% by 2030. And partly that's been done by reclaiming areas from industry, like the salt industry. They had salt ponds that were decommissioned and have been restored to marsh and are being restored to marsh. But they're also looking for other areas that are available in various ways and returning those to marsh. There's the sediment scarcity issue, which I talk about in some depth in my reporting. I won't go into too much detail here. But then there's also land use issues, which I see as a problem again and again, even in San Francisco Bay, where you have this really forward-looking program that has been underway for such a long time. There's still continue to be proposals for development right on the Bay, which is ridiculous because the sea level rise could be 5 to 7 feet by 2100. 5 feet is like a midpoint average. And so you're putting something in harm's way, basically. And then you're also taking that space away in terms of like the ability for it to be a sponge and kind of absorb. And so you're increasing risk to other areas as well. There was a really interesting study earlier this year that looked at the economics of a community investing in protecting a wetland. And they found that the return on investment in terms of like reducing damage to neighboring properties was often paid off in less than 5 years. So there's a lot more to say about that, but I'll leave it there.
And maybe for me, I think Asia is a place to be watching. Asia has an enormous coastal population in low-lying coastal floodplains. It's about, 3/4 of the world's losses of coastal wetlands over the last 20 years occurred in Asia, of which just 3 countries contributed about 68% of that. That's Myanmar, China, and Indonesia. So we're seeing like ongoing losses of coastal ecosystems over there. But at the same time, we have this huge coastal communities that are likely to be impacted by sea level rise like very soon, if not already. And I think in that region, we'll see a range of responses. One, there's already been a bounce back of coastal ecosystems in parts of China, where restoration projects and a recognition of the importance of maintaining coastal ecosystems has already started. It's just starting now, I reckon. In addition, there's been stops on developments in South Korea, so stops on coastal developments that lead to large-scale losses of coastal ecosystems. So that's a pretty important recognition that these ecosystems are important for those millions and millions of people that live along the coastline there. And then maybe one other interesting thing that I think we'll see in parts of Asia is just this ability to develop absolutely enormous engineered solutions to sea level rise. Talking about the scale, size of Sydney Harbour or San Francisco Bay in itself, just for an engineered solution to sea level rise, I think in that region over the next 20 years, we'll see more and more really large-scale responses to sea level rise, mainly to protect the incredible amount of coastal infrastructure that's been built less than 10 meters above mean sea level. So it's a place to watch. It might not be a sort of hopeful place to watch, but it's also, you know, just accounts for so much of the world's coastal population and so much of the world's coastal ecosystems losses and so much of the world's low-lying coastal infrastructure that I think it is really a place to keep an eye on in the next 5 to 10 years.
Great, thank you. On that note, actually, we started to talk about the next question I have here. So engineered efforts like levees and seawalls, they're often prioritized over restoration to adapt to coastal erosion. So, for instance, Louisiana has a $50 billion plan for their coastline, which seems to incorporate, you know, building some of these levees and also some marshes. So my question for all of you is, what questions should journalists be asking in regard to these massive infrastructure projects? How should journalists balance the discussion here of the benefits of these engineered solutions versus the environmental impacts that they have?
I hope that journalists take an extremely skeptical view of these kinds of projects, because they are that single focus solution that we talked about. And, you know, Nick and RJ have talked a lot about how coastal ecosystems are so incredibly dynamic. So imagine taking that very dynamic, complex system and sticking a wall in the middle of it. You know, that wall is immobile, right? And so all of this movement is totally incompatible with that immobile wall. So what you have is, like, often the wave is scouring out underneath the wall. So this requires almost constant maintenance. And then it's definitely an environmental justice issue, right? You can't wall off the entire coast, and places who can't afford a wall, that wave energy is then deflected and increased on neighboring people. So you're increasing the impact on someone else. And a lot of times these highly expensive engineered projects are, people don't actually build them because they just won't work. Like, you know, New York was considering one around all of New York Harbor. I think Boston was considering a similar one around Boston Harbor. And, you know, these projects take 25 years to build. They cost $100 billion or more. And, you know, maybe they're blocking against sea level rise. Are they blocking against storm surge? Are they blocking against, you know, when you have a massive rain and you have the water coming from the other direction, then are you trapping that water? You know, some of them have mobile doors, but, you know, they're only going to protect against X number of feet, but then sea level projections could be much higher. You know, you're trying to build something and you don't know actually what you're building for, because there's still a lot of question about how much, you know, how much sea level rise we could actually be experiencing, how big the storm surges could be, how often the sunny day flooding is going to be happening. You know, these solutions often don't protect against sunny day flooding at all. So in general, I would just say, like, restoring these natural ecosystems that have the ability to be flexible and buffer and then also using that money instead for targeted pullback from the coast to allow that space, I think is a much more resilient long-term investment.
Yeah. I think, you know, because the other thing is, you know, are these hard engineered efforts sequestering carbon? Are they providing fish nursery habitat? Are they cycling nutrients? Are they providing rich havens for biodiversity? You know, so yeah, I think a skeptical approach, you know, really questioning, is this a judicious use of funds? You know, because if you weigh it all up, and I'm not one for valuing nature, but, you know, even just on some of the ecosystem services there, you could go, well, actually, the maths doesn't stack up here.
Yeah, I absolutely agree with what's been said on this question. A skeptical approach is vital for heaps of reasons. One is that we're working with just such a complex system. It's not easy just to drop one intervention into a complex system and hope that it works. It can actually cause a lot more trouble than than it might otherwise cause in allowing a complex system to respond in its own right. Things like engineered solutions can increase compaction and subsidence, so they can actually sink the sediments and cause an increased rate of what's called relative sea level rise, which is sea level rise combined with the sinking of sediment. So there's some risks here, and I think if I had to give some suggestions to journalists as well, it's to be open-minded about those types of risks. Are these interventions sensitive to the needs of biodiversity? It's not just about sea level rise we need to think about when we're thinking in the coastal zone. And yeah, just that intervention in a complex system is really worth pursuing, because it's often not a simple matter of just putting up a seawall. It can cause impacts to coastal environments 50, 100, 500 kilometres away just by interrupting those natural coastal processes.
Thank you all for your. Sorry, go ahead, RJ.
No, I was just going to say, I think we see this a little bit in more. I mean, it's not coastal, but riparian systems, and I mean, Eric, I'm sure, can speak to this. But you know, we put some increasingly, we're seeing flood defences in our river systems across the UK, but every time that water is prevented from going into a field and being taken up like upstream, it's ending up traveling downstream, and it's going to end up breaking the levees somewhere downstream. And so I guess this is the whole purpose of the book, Water Always Wins, but it's going to have an impact elsewhere. And so there's never going to be a simple fix to a complex issue.
And it often makes the problem worse, like Nick was saying. So like your example of riparian issues, you know, there are 3,500 miles of levees along the Mississippi River. And the Army Corps of Engineers evaluates every levee proposal individually, even though they recognize that the impacts of levees are cumulative. So when you're blocking rivers off from the floodplain, when you're not allowing the water to spread out, which is the fundamental way it slows and reduces flood peak, you're actually increasing the height of the river, increasing the risk for every area downstream. So, you know, they have to levee up taller, but, you know, water people have a joke about levees. There are two kinds, ones that have failed and ones that are going to fail. And so, you know, if you have a lot of things that are built behind there, then you're increasing the damages. And I'll just add, so that 3,500 miles of levees over the course of the 20th century, the flood height at St. Louis has increased by 13 feet. So, you know, it's really dramatic. And it's similar in terms of, you know, distributing the impacts of that hard development when you're looking at coastal issues.
It's also the cumulative impact it has on the ecology as you go downstream, as you go down that estuary, isn't it? Because the hydrodynamics are changing as you're building up. You're not allowing that flood peak to dissipate, and so actually you're having an impact on the coastal ecosystem where the estuary meets the sea. And like, so this again, it's just embrace the complexity.
Great. Thank you all for your comments on that. On that note, Erica, this question is for you here. So you have done tons of reporting on gray versus green infrastructure approaches, and how some cities are adapting to ongoing, flooding or adopting or readopting green infrastructure techniques. So the question is, what are some of those techniques that are being adopted by communities or cities that you think journalists should be really keeping an eye on?
Yeah, I think the basic idea is that we need to make cities more permeable. So, cities are largely pavement and asphalt, and that doesn't allow rainwater to sink in where it falls. And so that increases urban flooding. There's been a huge increase in urban flooding over the last few decades. And it also contributes to water scarcity, because people's response to flooding is to try to get rid of the water as quickly as possible. And then you don't have that water later. So like in the Western United States, people tend to think of streams as seasonal, but in fact, historically, many of them ran year round because they were supplied with healthy groundwater that was fed by water being able to infiltrate and raise the water table. So what people are doing in cities are many different ways of trying to make the land more permeable. That can be permeable pavement, but that is not my, I don't think that is the ideal one, because there are many opportunities to actually make spaces for ecosystems within cities. So a larger impact might be river restoration. A lot of cities are built along rivers. A lot of industry was historically along rivers, and a lot of those industries have gone elsewhere or closed. And so then you have a lot of brownfield sites along rivers. And so remediation and restoration of those areas and returning them to parkland is a good option, because then when you have those high flows, you can allow them to flood. Floodplains exist to absorb floods, rather than putting more buildings within that harm area. There's a lot of incentives that people can do in terms of, street trees, bump outs, medians, etc. Incentives for native plants rather than lawns. Lawns are the largest irrigated crop in the United States and use tons of pesticides. And so, what plants that evolved to a particular place don't need supplemental water, which is a significant part of the water consumption for residential use. When it comes to like green infrastructure in cities, sometimes you see things like, a field, like a soccer field that has a stormwater tank underneath, or, a parking lot that has a stormwater tank underneath. And those are really not green infrastructure. They're often touted as green infrastructure, but really it's just more of the same kind of gray infrastructure that has a certain capacity and is built of concrete, et cetera, and is not contributing to the ecology of an area. Green roofs is an option. But in all of these things, I would just say scale matters. So, humans have drained and filled as much as 87% of the world's wetlands, dammed and diverted 2/3 of the world's rivers. And like I said, the land area covered by pavement in cities has doubled just since 1992. So in all of these ways, we have interfered with the natural water cycle, the ability of water to infiltrate into the land and do all the important things that water-land interaction does. So when you're looking at an urban solution, like sponge cities in China, I've written about, and it's gotten a lot of attention elsewhere. And it really is ambitious and it's national scale. But so far, the projects are, maybe 5 square miles of a city that might span 1,000 square miles. So, if you're reading a story about how a particular city in China flooded, even though it had sponge cities, if it's such a small area, it can't make up for all of that area that we've taken away from water. And so the solution has to be at scale as well. But you also hear people saying that, nature-based solutions are nice, but they can't be a significant part of the solution. But again, that's a misunderstanding of the scale. They definitely work, and there are places that are starting to scale up that can be examples.
Great. Thank you very much for chiming in on that, Erica. If anyone else has anything to add about gray versus green infrastructure, feel free to do so. Otherwise, we can move on to the last question here. Okay, so is there anything you all wish that journalists would do more of in their coverage of either coastal restoration projects or any of the other coastal climate solutions we've covered? What are the gaps in reporting happening, and what kind of stories should journalists really be looking to cover?
Again, it comes back to complexity and nuance, but I think one of my personal bugbears with particularly seagrass and carbon is the way that there are 70 different species of seagrass globally. They come in different shapes and sizes, and they all do different things. So we don't have just one seagrass that grows all the way around the world in the same way we don't have just one tree. And so what we're seeing in terms of the science, in terms of like carbon stocks and storage, is actually huge variability, even within species. So if we compare a couple of species, you've got some holophilers, for example, which are very small seagrasses, and they're not particularly famed for their carbon storage or sequestering potential. We've got species in the Mediterranean like Posidonia oceanica, which is kind of like the oak tree, I guess, of the seagrass world, very slow growing, but it's incredible carbon store. And so there's just massive variety in between species there. And then when we look at the species of seagrasses we have around the UK, we're doing some work on this at the moment. And actually, there's a huge variability in the amount of carbon that's being stored in these systems and is being sequestered in those systems based upon the location that seagrass is found. So we actually find the sort of geomorphological setting, or whether it's an estuary or a loch, or whether it's in like an exposed coastal, exposed stretch of the coast. All of those drivers have an impact on the rate at which carbon is sequestered and the amount of carbon that's being stored in those sediments. So it's very difficult then to metricize that, because every location is slightly different. And so again, it just comes back to this idea that natural systems are inherently complex, and it's very difficult then to give like a very clean answer when there is just so much complexity.
Yeah, well, for me, at least in the scientific literature now, there's sort of increasing recognition about where we're gaining coastal wetlands in places that they weren't before, which is a response to sea level rise in itself. And so, for instance, there have been some spatial analyses of the growth of what's being called ghost forests in the US, which are formerly terrestrial forests, which are now getting inundated on the very highest tides with salt water. Which is essentially just leading to those forests dying off and slowly beginning the process of converting to coastal wetlands. It's not something we see very much in the media yet, but I think that observed responses to sea level rise is a really interesting thing that people want to know about, and I think it can help sort of put a connection with a really slow operating process like sea level rise to start shining the light on those sorts of processes, new coastal wetlands, new incursions of seawater on low-lying coastal farmlands as well. That's the sort of thing that I think there's going to be a real interest in, if not already, that would be really, really neat to sort of focus on a little bit more.
Yeah, I think for me, the idea of one ecosystem being connected to another is really important, like with the tidal marshes in San Francisco Bay. The mud flats and the low seagrass and the mid and the high seagrass and then the oak uplands, it's all a continuum, and they interact with each other. They're exchanging nutrients, they're exchanging water. And so, whatever is happening on the coast is also impacted for better and for worse what's happening in these other systems. And then I would also ask that journalists think slightly down the road. So in terms of like developments that are planned at sea level or close to it, a lot of times communities advocate for these projects, because they have a need. They need housing, or they need a new airport or whatever. But often they're also motivated by that tax base, right? The taxes that they're going to get from this new development. And, the developers don't care. They build it, they sell it, they move on. But the city is very quickly going to be on the hook for continuing to supply services to this area, roads, clean water, drinking water, sewage treatment. And those can be very quickly impacted by sea level rise, even before land is inundated. The seawater can push up groundwater from below to cause flooding. It can turn the water salty. So there are many near-term impacts that could very quickly offset whatever tax benefit a city is getting. And that's something that I very rarely see covered, and I would like to see more of it.
Great, thank you all. Really quick before we begin our audience Q&A here, are there any resources, databases, mapping resources, or websites that you really want journalists to take advantage of?
Well, IPCC is one just wealth of information about observations of the impact of sea level rise on the coastal zone already. And then just a quick plug of a couple of products that I've been involved in over the years would be the Global Intertidal Change website, which is a an analysis trying to monitor changes of coastal wetlands of the whole world. And one of the things with that is that we don't work on just mangroves or salt marshes. We call these systems tidal wetlands because what we want to look at losses of mangroves that convert to salt marshes. It's really important to look at all of them at once. Global Mangrove Watch is a really important website as well that offers free spatial data and summaries of where mangroves are changing globally as well.
Yeah, just as a resource, I mean, this is a broad resource for journalists. Really, is the conversation. I don't know if you've come across that as a website, but that's always a really good, I think, source for getting information, which is not written like a paper, but it's written in a way that's accessible. So I always find that pretty useful. I could give a plug for our own website, Project Seagrass. And but equally, actually, James Cook University Seagrass Watch. There's a whole bunch of really good resources out there. Yeah, I mean, Erica.
Thanks. Yeah, so my website for my book is slowwater.world, and I have a lot of information there. Also, I talked a lot about my reporting in San Francisco Bay. There's a fantastic scientific organization there called the San Francisco Estuary Institute, and they do incredible research and reports and are just a real treasure trove of information. I write sometimes for Hackeye magazine, which a lot of journalists have probably heard about, but they specialize in coastal issues around the world. They're actually based here in Victoria, where I am now, but they do really, really excellent reporting. So they're a great source to learn more about issues and potentially also to pitch, not to undermine Mongabay, which also does great coastal reporting. And then there's another website I came across, which is not coastal issues per se. It's like water more broadly, but it's called Water Stories, waterstories.com. And it's a lot of people who are doing kind of various types of nature-based solutions. And so there's like how-tos, but also they have these great webinars with scientists that I found really interesting.
One final one. It's the UN Decade on Ecosystem Restoration at the moment, and that runs from 2021 through to 2030. And so I think it's just decadeonrestoration.org. But the home site for the UN Decade is a great resource for lots of international coverage on the various restoration projects globally.
All right. Thank you all so much. Those are all helpful. And just a reminder to everyone watching, I will later put those in the show notes of this episode a couple days from now. We're going to go ahead and move on to our audience questions. That concludes our main panel here. And we're going to get to as many of these as we can, but we will have like a hard stop in about 15 minutes or so. Sorry, RJ, did you have anything to add there?
No, that's it. No.
Okay. I'm going to go ahead and move on to the questions now. So there's a lot to go through. Starting with the first question here from Ashley H. Can you please talk about top-down restoration plans, i.e. reintroduction of species like sea otters? More studies are showing the importance of wildlife regarding climate change resilience.
Yes, I guess one of the things that we increasingly see or are increasingly understanding is the importance of those interactions. So, restoring a seagrass meadow, to use the seagrass as an example, you're restoring the habitat, and you're actually creating seagrass as an ecosystem engineer. So it kind of changes the whole environment in which you find it. But what we also need to understand is that it's a complex food web, and so the ratio of different organisms within that environment will have an impact on actually the functioning of that ecosystem. So whether that's the amount of grazers present, whether that's the amount of sort of intermediately sized fish, whether that's the presence or absence of an apex predator. And so we also see with the reintroduction of organisms like otters or beavers that they can actually engineer their environment as well. And so increasing amounts of work are being done on those interactions and how that affects the functioning of the ecosystem overall. Even within a sort of a habitat up restoration perspective, we also see that, going back to that connectivity, different habitats restored in different locations may end up evolving slightly differently in terms of how they express themselves, depending upon things like larval supply into the region, or the presence of seeds, propagules being able to reach that particular destination. So these coastal systems are highly complex.
Yeah, and I think an important thing in terms of all of the services that these ecosystems deliver is the more intact and healthy your ecosystem is, the more it's going to be able to maintain itself. So some restoration projects require kind of ongoing maintenance, almost to the level of the maintenance required like for a seawall or a beach renourishment. But if you have all of the key players, and if they have the ability to be connected to neighboring ecosystems, they can maintain themselves to a much greater degree, which makes them more stable and also resilient and less expensive for people as well to keep up.
All right. I'm going to move on to the next question here. This one's from Tina S. What's the link between plastic recycling companies that collect plastics from beaches and waterways to coastal solutions? And can I pitch this as a story? And I think I can safely say you probably can pitch that as a story, but I'll go ahead and let our panel here chime in.
I've done a fair bit of reporting on plastics in the past, and collecting plastic from a beach is not a solution because it doesn't deal with the source of the plastic pollution. And the sources are primarily land-based. Plastics that go to recycling or to the trash can get displaced by flooding or storms or wind, or just being dumped and make their way into the oceans. And then there are also plastic waste that coming from ship wrecks and issues when they're carrying cargo. And so, a beach cleanup can feel good and it can make the beach look better for a short period of time, but it's not a significant, it's a drop in the ocean in terms of the scale of the problem. And so what really needs to be looked at is like how we're handling those plastics and managing them and making sure that they don't go astray into the ocean. And more importantly, how can we move away from plastics for many things?
All right, I'm going to go ahead and move on to the next question here. For the Coastal Climate Solutions Special Reporting Project, is Mongabay open to pitches about parallel coastal waterways, such as rivers that feed into oceans, given these ecosystems' interconnectedness? I'm working on a project that I think would be a great fit that touches on several topics mentioned here. Abigail, that's a really good question, and there's a lot of complexity there. Without knowing the substance of your pitch, it's hard to say. I would say, yes, you can probably pitch that as a story. But again, I'm going to let our panel talk about the interconnectedness of these two systems.
Yeah, I think there's a really strong story there. And I think there's probably an example on a smaller scale that we were involved with about a decade ago somewhere in Indonesia, which was working with the coastal community. The seagrass meadow was being degraded at the end of the estuary. And one of the things that the community did to mitigate the effects of or the degradation of the meadow was actually to replant the riparian ecosystem. And so it's that, again, that connectedness by addressing the upstream issues, and they were able to conserve the seagrass meadow and conserve the fishery associated with it because of the work that had been done upstream. So it was nothing to do with the seagrass meadow itself; it was the upstream effect of replanting riparian habitat. So, yeah, I think there's a very strong story there, and really it speaks to that need to think about connectivity again.
Great, thank you, RJ. I'm going to go ahead and move on to the next question. I want to get to as many as I can. This one's from Maria. Thank you for this discussion. I'm currently reporting on how a community is restoring salt marshes in Spain. What are specific things I should be wary of when covering this from a solutions focus? That's a great question.
I guess solution for what? So, with all nature-based solutions, nature-based solutions are great for nature. Putting nature back is obviously a great thing for nature, but it's not necessarily a solution to the climate crisis. And that's where I think the word solution can sometimes be a little bit misconstrued. And so, what is it a solution for? Is it carbon sequestration? Is it biodiversity? For what's the reason for the restoration of the salt marshes? Because I see a lot of comparisons between different habitats. Seagrass does X compared to tropical rainforests, or salt marsh does Y, or whatever it may be. And I don't necessarily think those comparisons are particularly helpful, particularly when you're comparing blue carbon ecosystems and green carbon, or like land and sea marine systems and terrestrial systems, because they're working in different ways. So just ask, what's the why behind the restoration of the salt marsh.
Great, thank you, RJ. The next question here is from Erica. Do you think there's enough coverage on Africa's coastlines?
Definitely not. I mean, there's not enough coverage on Africa generally. And, I have been to various countries in Africa, and I have pitched stories, and, it's pretty hard to get certainly North American publications and even European publications to be all that interested in Africa, which is a problem, I think. But I will say that, there are really, really significant coastal loss issues happening on the west coast of Africa that deserve way, way more attention. And so I would encourage people to look into that. And then in terms of like getting broader based publications to care about them, that's really tricky. I'm not sure I have good tips on that.
I think there's also, again, there's because there's such poor coverage, it's actually difficult to get a real picture, I think, of what's happening there. But from some of the work that I do know of, there's some really positive things happening as well. So I think there's a lot to celebrate. There's an organisation based in Edinburgh called Plan Vivo, who are do a lot of work in, I think, Kenya in particular. And certainly from a seagrass perspective, there's increasing amounts of work being done on seagrass meadows on both coasts of Africa. And so there's a lot of really good stuff that should be in the news and should be being covered. So yeah, there's not enough. There should be more.
And I think too, when I have a chapter on Kenya in my book, and I wanted to include an example from Africa because that's where the population boom is happening this century. So, the population of the continent went from 1 billion in, at the turn of the century, and is expected to hit 4 billion by 2100. So, that is an opportunity, right? Like, we have made a lot of poor decisions in our development so far, and these places are developing. I mean, some of them are already developed to a significant extent, but there's going to be a lot more development. And so that's an opportunity to make different choices and to do things differently. And so that's kind of like the lens in which I wrote my Kenya chapter. And I think I'm really intrigued by that angle personally.
And I think I'll just jump in and say there's a really strong scientific literature coming out of Africa right now, particularly about the degradation of coastal ecosystems. It might not necessarily be the losses that we talk about when we talk about other places in the world, but just an inherent degradation of the quality of those systems is a focus of scientific research in that area. So I think there's a lot of information for journalists to draw upon in reporting that. It's just a matter of spruiking that. And I agree, as the future centre of global population growth, it's important to get working in that area if we can.
And while we're on the topic of Africa, I might as well let the audience know Mongabay is actually opening a bilingual bureau in Africa, for which we are hiring for a couple of positions. So do check out the information on that. And we are actually going to be releasing a podcast in the coming weeks that explores the Congo Basin that I am working on currently. So I encourage you all to look for when that will be released, roughly 7 to 8 episode series, give or take. Another follow-up question from Erica here. As we journalists report on solutions, should we include government response to the solutions in our reports?
Yes.
Yeah.
I guess I'm trying to think about what she means by government response. Does she mean, is government supporting these solutions? Is government recognizing that they work? I'm not quite sure what she's asking there, but governments can play a large role in what happens in an area. So I think their various responses are relevant.
Yeah, I agree, and I think obviously there's different press freedoms globally, but putting pressure on governments to make good choices, I think, is always a positive step. And so, yeah, certainly if a government isn't making good choices, it's always probably worth making that known.
All right, everyone, that is all the time we have for. I just wanted to give a big thank you to our panelists here for joining and providing their expertise and insight. And as always, to our audience here for participating in this webinar series, which we really hope that you are getting a lot of information from. We're excited to keep on continuing it. So if you RSVP'd to this event, you will receive an email containing a quick survey asking for your thoughts. I would really like it if you would fill it out and let us know what you think so that we can keep improving these discussions. And once again, this webinar will be published on our YouTube channel immediately here. And then in 24 to 48 hours, along with timestamps and resources that were mentioned here. And then we'll be publishing a link to this video on our blog at mongabay.org as well. So if you have ideas that you want to pitch to us, please do so at our opportunities page at mongabay.org. Scroll down, click on Coastal Climate Solutions, and sign up for our occasional email newsletter there, which shares new paid reporting opportunities and job openings with us. And please do subscribe to our YouTube channel here. Follow us for future discussions so that you can get updates about all of them via Mongabay's social accounts from Facebook to LinkedIn, Mastodon, and others, where we will post announcements and updates in advance of each of them. And if you haven't already checked out our podcast series, the Mongabay Newscast, which today's panel member Erica was a recent guest on, I highly recommend you give that episode a listen. Our next webinar will be about investigating supply chains and products, so watch for news about that soon, and I really hope to see you all there. So panelists, thank you so much for joining. It was a pleasure having you.
Thank you, Mike. This was
Thank you.
fun.